Hi students, this is a video on factoring polynomials. You've been factoring quadratics for a while, and we're going to take it a step further to see how we can factor polynomials of a higher degree than 2. Okay, so for any polynomial p of x, x minus a, let me fix that a there, is a factor if and only if, that means it goes both ways, p of a equals 0. So in other words, if I put that solution a into my polynomial p of a, I will get 0, right? Because if it's a factor, if x minus a is a factor, then that solution is an x-intercept. So let's see what that looks like. So here I have a polynomial x squared minus 3x minus 18, so this happens to be quadratic, and I'm trying to see if x minus 6 is a factor, okay? And basically what that means is that there'll be no remainder when I divide it out. So I'm not going to run you through the whole problem, but basically I do my polynomial long division, and I see that it has a remainder of 0, therefore x minus 6 is a factor. Likewise, if I do synthetic division, I see that I've also got a remainder of 0, which tells me that that 6 is a solution, or x minus 6 is a factor. So here's another problem. Given x plus 2 and p of x equals 4x squared minus 2x plus 5, is x plus 2 a factor? So I see when I do synthetic division that I get a remainder of 25, so no, x plus 2 is not a factor. Okay, so now we're going to look at something new, factoring sum and difference of two cubes, and then move into some polynomials of higher degree. So let's think about our cubes. I'm going to write my perfect cubes. Just down the side of my page here, it's 1, 8, 27, 64, 125, 216, etc. It's really important to know your perfect cubes. That's going to be super helpful when you need to recognize perfect cubes. So basically, examples of perfect cubes. I have x cubed plus 27y cubed. That's a sum. That's a sum, right, of two cubes. X cubed is a perfect cube, and 27y cubed is a perfect cube. And then 8x cubed minus 64 is a difference, right, because I'm subtracting, and 8x cubed is a perfect cube, and 64 is a perfect cube. So these are examples, and now I'll show you the pattern that we use to factor these. Okay, so here is the formula for finding, for factoring a sum or difference of two cubes. Okay, so my sum of two cubes, a cubed plus b cubed, is a plus b times a squared minus ab plus b squared. So there's an acronym that we use to kind of help us remember this, which is SOAP, S-O-A-P, and that means same sign. Whoops, I'm sorry. Let me go backwards here. That means same sign, opposite sign, always positive sign. Down here for a cubed minus b cubed, it's still, we can use SOAP as an acronym to help us remember the signs. Same sign, the minus, right? Opposite sign, plus, always positive. So it's a little bit helpful. You still have to remember the general format, but that helps you remember the signs. So please right now take a minute to stop the video, put this in your notes. This is also a really good thing to go in your notes, your perfect cubes, so you start to study them and remember them. So stop the video for a second and put these things in your notes for sure, as well as the following example problems. Okay, so here's an example. AY cubed minus 27. Is it a sum or difference of cubes? It's a difference. It's minus sign. 8y cubed is a perfect cube, and 27 is a perfect cube. So you can see now why memorizing your perfect cubes is really helpful. So let's identify A and B. A is the cubed root of 8y cubed, which is 2y. B is the cubed root of 27, which is 3. Okay, so that's going to help us. Remember, it's A minus B, so 2y minus 3 times A squared, which is 4y squared, plus AB. In this case, AB is 6y, so plus 6y, and then always positive. B squared is plus 9. Okay? So put that example into your book, please, into your notebook, please, and we'll do another one. Okay, so at first glance, this one does not look like a sum of cubes, but the first thing we always want to do when we're factoring is look for a GCF. So I'm going to see, very first thing we do with anything we're going to factor, and I can factor out a 2x squared, and I'm left with x cubed plus 8. And that is a sum of cubes. So I can rewrite that as 2x squared. And I know my A equals, it's really helpful to write this, A equals x, B equals 2. Kind of helps us out here. It's a sum. So I get A plus B, which is x plus 2. And then A squared, which is x squared, minus AB, so minus 2x. Always positive, plus b squared is 4. And that's as far as I can factor it. By the way, as we get further on, when you're fully factoring things, we can use the quadratic equation to factor that and we might have an irrational solution or a complex solutions, irrational complex solutions, as well as some real solutions. Okay, so let's do one more. Okay, so it's a difference. I've got a minus sign, perfect cube, 125 x cubed, 64 is another perfect cube. And I know in this case my A is 5x, my B is 4. So again, really helpful to know your perfect cubes. Okay, so it's a minus, so I have same sign first. So it's 5x minus 4. And then A squared is 25x squared plus AB, so plus 20x, always positive, plus 16. And again, I'm not going to be able to factor the quadratic I'm left with, but I could use the quadratic formula on that. We're not going to do that quite yet. The last thing we're going to look at is just factoring by grouping, which you've done plenty of. We're just going to revisit that in this lesson. So if you have a polynomial and it's not a sum or difference of cubes and you've got 4 terms, you always want to look at, can I factor by grouping? You should have done plenty of this. So we can factor out an x squared here, and I'm left with x minus 2 and a negative 9 here, and I'm left with x minus 2. I end up with x squared minus 9 times x minus 2, and be careful because you're not done here. This is still factorable. So you're always looking to see when you're done factoring, can you factor some more? X squared minus 9 is a difference of 2 squares. I get, whoops, go back there, x plus 3 times x minus 3 times x minus 2. So you're going to see this come up a lot in your work where you're going to have to factor further. So always look to see, what am I left with? Can I factor further? Okay, because we're going to be doing a lot of multiple steps of factoring. Okay, so that's it. Please make sure this example's in your notes too, and that's it.